Hello, my name is Bhavin Soni, and my presentation is on mobile cloud computing and the integration of a biometric authentication framework via facial recognition. So when we talk about cloud computing, we're talking about a paradigm of computing that delivers on-demand services to consumers with a pay-as-you-go method. And the services they offer range from cloud applications, data storage, network configurations, and many more resources. Now, mobile cloud computing is an extension of cloud computing. Essentially, it's a combination of mobile computing and cloud computing combined. Mobile cloud computing delivers the same management of resources in cloud computing with no on-premise software, regardless of where the user is. So the problem we're trying to solve here is issues with authentication. With so many resources and sensitive data at your fingertips, privacy and unauthorized access is very important to handle securely. A lot of times, passwords and credentials are stored in mobile devices, which makes basic password authentication less secure and easy to take control of. Malicious attackers or users may be able to take a mobile device and get access to any cloud computing service or application and violate or manipulate the user's data. Here we introduce biometric authentication. With this, we rely on behavior or physiological characteristics of an individual to reduce the likelihood of a malicious user gaining access to mobile cloud computing services. In this research, we propose that facial recognition would be the most feasible authentication type due to the improvement in hardware and software in mobile devices today. Fingerprint scanning has been around the longest in mobile devices, and so it's the most researched. Apple released Touch ID in 2015, whereas Android released theirs around 2014. Facial recognition is still relatively new, and we see that with Apple's Face ID and Android's Face Unlock softwares. These methods of authenticating are becoming more popular, and we see that with unlocking a phone or a mobile device. So in this research, we hypothesized that it would be more effective and practical to integrate a facial recognition framework at the cloud provider level than using a fingerprint scanner for user authentication. In this slide, we'll go over some related research that others have done. First being continuous facial authentication, where the researchers of this paper authenticate users by continuously capturing images of a user's face with their mobile device. The user is first prompted to log in when their mobile device is on. The image's template is updated, and there's some time that's being waited. From here, the image gets captured again, and it becomes validated. And this process continues to go on while the mobile device is on to make sure the person using the device is who they say they are. Though this provides maximum security to someone who hasn't logged out of the device, this requires the server to keep authenticating and capturing images, which produces massive overhead when there are many users and can become very costly. The second paper we look at is fingerprint authentication through image capture, where researchers take images of a user's finger and pinpoint all unique identifiers on the finger. And from here, we see that an image of a fingerprint is created and captured here, and the software they implement maps all the points of the finger to create a unique identifier to authenticate the user. This can work on all mobile devices, but it becomes infeasible to map all points to a finger rather than take a facial image and pinpoint more prominent features such as eyes, nose, and lips and average out the distances between them. Lastly, we look at biometric framework via fingerprint, where researchers of this paper propose a similar solution as I do, but more generalized for all cloud computing. And it's done through fingerprinting. So this could work. However, researchers of this paper want the cloud provider to supply all the hardware, so it becomes very costly and impractical to carry a fingerprint scanner with you at all times. For my experiment, I wanted to show the accuracy and effectiveness of facial recognition. So I tested with both Android and Apple devices. Due to limited knowledge in creating a facial recognition software, I used the native biometric authentication softwares on the devices that I own. I used an Apple iPhone 12 and a Samsung Galaxy Note 20 for facial recognition, and an Apple iPad Air 4th generation and Note 20 for fingerprint scanning. It would have been better if I had one Apple device to do both authentication methods. However, Apple decided to remove fingerprint scanning and put their faith on the robust Face ID software on their newer devices. Here we test against fingerprint scanning because of the abundance of research with fingerprint scanning and how it's regarded to be a popular way of authenticating a user. By doing this test, we create a baseline for facial recognition. The first test I did was measuring the amount of successful authentications in each device for each authentication method. I did 50 authentication attempts on each device. An attempt is considered when a user tries one of the authentication methods. A successful authentication is when the user is able to log in to the device with no problems. For the results of this test, here we see Apple being slightly more successful in authenticating a user based off their facial recognition software as opposed to the fingerprint scanning. On Android, we see that the Face Unlock software was considerably more successful in authenticating a user as opposed to their fingerprint scanner. The second test I did here was to time the successful authentications for each device for each authentication method. As stated previously, a successful authentication is when a user unlocks the device with no problems. Here the times were estimated due to no native software to log device unlock timings. The timing was started from when the user initiates the device authentication until the user is successful in unlocking the device. In this test, we see both authentication methods in Apple devices let users be authenticated in less than a second. However, on the Android side, there is a considerable amount of time difference where the face unlock timings were noticeably faster than the fingerprint timings. So the results. From these tests alone, we can see that the native facial recognition software in mobile devices are just as accurate and effective, if not better, in authenticating users than fingerprint scanning. Obviously, there are many variables that play a role here, including the fact that these tests have such a small sample size and that there are many variations of Android devices with different hardwares and softwares, as well as different obstacles in authentications, like sweaty fingers, aging, lighting, or even differences in the hardware and software for cameras and fingerprint scanners. Therefore, more thorough testing does need to be conducted to come up with a more accurate result. However, from the test conducted alone, we can see that facial recognition is a strong contender to fingerprint scanning, and that facial recognition has definitely come a long way today. Here, I demonstrate the biometric framework. This is a simple explanation on how the framework could or would work. We have the mobile user here, and this is a user with a mobile device who is trying to access any resources, data, or applications that are provided by the cloud service provider. The mobile user then initiates facial recognition, where it takes an image of the user or captures an image of the user and encrypts it with a facial signature. The facial signature then goes down to the cloud service provider, which then sends it to the vault. Here we introduce the idea of a vault or a secure database, where this encrypted signature is decrypted and it compares it to the signatures stored in the vault. The vault is on the cloud service level and is only used to validate the signatures. No one has access to the encrypted data, and it should follow almost like a zero trust methodology. Once the facial signature is validated, the vault gives the cloud service provider the okay to go ahead and authenticate the user so they can have access to their data, resources, or any application. In case the facial signature is invalid or the facial signature recognition does fail, it will go back and prompt the user for facial recognition again. So, how will we implement this facial recognition software? The first way we can implement it is that we can utilize the native facial recognition software on newer mobile devices like Face ID or Face Unlock on Apple or Android. Many bank apps like the Bank of America mobile app are already utilizing these features. This would be the recommended and easiest route to take. This would cost very little or nothing for the cloud provider, but may be costly for a user to obtain a new device. However, in current times, many consumers already have devices with these kind of capabilities. Implementing it this way lets the responsibility fall under Apple and Android, but this authentication is thoroughly regulated to meet industry standards, especially if banks are implementing this already. The second is to adopt deep learning facial recognition as proposed by Zulfikar et al. I won't deep dive into the research, but I found it very interesting and applicable to this research. Here, researchers were able to use deep learning and integrate it to facial recognition by using convolution neural networking to accurately map a user's face three-dimensionally. Based on the results, they were able to successfully authenticate users with a 98% accuracy. This would let any user with a mobile device that has a camera to utilize facial recognition. It would cost nothing to the users, but may cost a little or some to the cloud provider to adopt this method and allocate resources for it. The only thing is that since it's not regulated, it may lead to poor security measures. To conclude, we show that facial recognition is very accurate and effective way in authenticating users in mobile devices. Using this type of authentication can improve the security and privacy of mobile users. Since fingerprint scanning is becoming less prevalent as we see in newer Apple iPhones or devices, facial recognition and a framework that we propose can provide a cost-effective and practical solution to mitigate the risks of unauthorized access or malicious users. So, for the future, we definitely want to see the framework implemented at the cloud service level in large scale. This would be the only way to test this solution accurately and effectively. Since the testing done in this research was very minimal, we would want to see more thorough experiments with native and proposed facial recognition methods on mobile devices. Lastly, since we push for Face ID and Face Unlock, we also want to see the solution applied to all mobile devices and not just the newer ones. Whether we implement deep learning methodology or integrate a multi-biometric authentication, this could provide a safer mobile cloud computing environment for all. And on this slide are the references used for the research. Thank you, and hope you enjoyed my presentation.